Let's talk about evaporator fan cycling. Our goal is to hit your room temperature set point value in the most efficient and accurate way. A properly configured room will maintain an even temperature throughout and run your evaporator fans only as it needs to. Cycling your evaporator fan saves energy in two ways. It saves the power required to run the fan and also eliminates the fan's heat load, which would otherwise need to be removed by the refrigeration system. The control basics for evaporators include opening and closing a liquid solenoid to maintain the temperature at the target set point. When the temperature goes up above the set point, the liquid solenoid opens and the coil begins cooling. When the temperature goes down below the set point, the liquid solenoid closes and the unit is considered satisfied. Dead bands above and below the set point are used to eliminate excessive opening and closing of this liquid valve. Along with the liquid valve, the fans are also the heart of all this control. There are three different modes for controlling the fans, or fan cycling: none, temp, and sample. By definition, none will not cycle the fan. This means that the fan will stay running when the unit is considered satisfied. Temp stands for temperature cycling. This means the fan will turn on and off with the liquid valve and use the fan on and off delays provided. When the unit starts cooling, the fan on delay is in place so that the coil can cool down and fill with liquid before pushing air into the room. Similarly, the fan off delay gives the coil time to pump all liquid out before turning the fan off. The last mode type is sample. Sample is designed to eliminate the buildup of warmer air near the temperature sensor and inconsistencies of room temperature throughout the cooled space. This is done by moving the air around at a set runtime interval. When the unit is satisfied, the fan will turn off, identical to the temp mode. Once off and while the unit is satisfied, the fan will remain off for the sample off delay and will then turn on for the sampling runtime to move air around within the space. While in the sample off delay, if the temperature rises above the set point to where the unit would normally start cooling, the fan is turned on for the sample on time before going into the cooling state. At the end of sample on time, if the temperature has risen, the unit will then go straight into cooling. Now, if the temperature comes down during the sample time, the fan will turn off and start the off delay over again. With this approach, the unit only enters cooling if absolutely required to control the temperature, and the fan remains off for most of the time your unit is satisfied. Deciding which mode is right for each evaporator depends on many factors. The purpose of this controls tool is to keep the fans off as much as we possibly can. Taking advantage of fan cycling can significantly lower your energy bill.